So hello all of you. Today we will learn about what's process management and operating system. So what's a process? So it says, as we all know what a process is, right? So we know the terminology. So it says it's a program which is under execution, right? And so that's called as a process. So for example, okay, let's say you want to make a cup of coffee, right? So it involves a process. That means it has so many things to deal with it to get the required output, right? So whenever we say a program, what's a program? Again, it's nothing but a sequence of steps. Similarly, let's say when we want to prepare a cup of coffee, so it has certain steps, right? There is a certain procedure as to how we would do it, right? So this is a process. Okay, so it says it is defined as an entity which represents the basic unit of work to be implemented, okay, within the system. So here they're trying to tell, okay, we write so it says in simple terms, it says we write a computer programs in a text file, and when we want to execute this program, it becomes a process. So if you see, okay, especially whenever you're going to type a program in any one of the editor, yes, it has a lot of steps that you would follow, okay, the syntax that you would follow. So it's again a program, right? When you click on run, okay, so what happens? Basically that file is getting loaded, right, and where into the main memory. So all of us know that the programs that are brought in the main memory are the ones that are getting executed, right? So that's what it says. When a program is being loaded into the memory and it becomes a process, okay, it can be divided basically into four sections. So we have stack, heap, text, and data. Okay, so this is how it would look like. Okay, so you can just imagine anytime the next time you're going to write a program, and when you click on run, this is how your program is being divided into. Okay, so you have the stack, you have the heap, okay, we also have the data as well as the text. Okay, so whenever we say stack, so it says the process stack contains the temporary data, okay, such as the method or the function parameters that returns the address in the local variable. So whenever, okay, you think of a stack, it's like temporary data you are stack, or let's say for example when you're trying to stack things one above the other, okay, when you stack it up, definitely you are removing it at one point of time, right? So you can just imagine that a stack as of a temporary data storage. Okay, the next thing is the heap. So heap is something, okay, that is dynamically increasing during runtime based on how much memory that your program would require, right, during the runtime. So that's nothing but the heap. So if you can see here the diagram, see the stack is being very constant, but when you see the heap, there are arrows which says, okay, the upward and the downward arrows which says that it can increase. Okay, so that's what it says. And you also have the text. Yes, it has the text wherein which it says it includes the current activity represented by the value of the program counter and the contents of the processor's registers, and the data, yes, which also contains the global as well as the static variable. So now comes the process life cycle that we see, and which is the most important thing, I would say. So whenever we say life cycle, so from the beginning to the end, from the beginning of a process to the end of the process, so what is that journey through? So we will now see what it is. So basically it's it has five stages. So we have new, we have running, we have waiting, we have ready, as well as we have terminated. So this is how it would look like. Okay, so when a process is being born, okay, or let's say it's being introduced, or it's being created, okay, so that is when we state that this particular process is in the new state. Okay, or we also call as the newborn state. Okay, and the next thing is when the instructions are being executed. So if you can see here, we have a running here. That means, so before that you have a ready. That means all the processes, okay, that are being created and that is now, okay, ready for execution are being put into a queue, and that queue exists, okay, within the ready state. Or I would say the ready state consists of all the processes wherein which it is now ready for getting executed in a queue. So as all of us know what's a queue, so it basically follows the first in first out manner, right? FIFO. So that is what is the ready state. And then you actually have the running state. So it says whenever we say running, okay, that means you have all the processes that are currently, okay, running, or that the it has been dispatched from the ready queue, okay, to the running state, and now the processes that are being brought to the running state are the ones that are being executed. Okay, and the next thing is the waiting. So it says the process is waiting for an event to occur. Certainly, Let's say, for example, okay, when a process goes to the running state and there is some important IO event, let's say you want to print something before the running the program. Okay, you had clicked on run and then now you want to print. So what happens? The program is not fully executed. It now goes to the waiting state, right? For a particular event to occur. So after that particular event is done, it is again being placed back into the ready queue. And again, okay, it will be sent to the running state, okay, through the schedulers. Okay, so we have the dispatch scheduler who's basically dispatching the processes from the ready queue to the running state, or let's say from the ready state to the running state. So it can either go to the waiting state if there was an IO or an, a wait, okay, that you would normally, put that in the program. It depends on how it is, and or let's say what context you people are running. So the next thing is, for example, from the running to the ready. So let's say if there is an interrupt, okay, there is some interrupt. So it could be an internal or an external interrupt, a software or a hardware interrupt. It could be anything, okay. So let's say if there is an interrupt, then it would go back to the ready state. So, and the last one is a terminated, wherein which after successful execution of the program, the process terminates. Okay, so this is nothing but the life cycle of a process. And about PCB we will see in the next session. Thank you all.